Hello and welcome to today's webinar. Today, we're going to walk you through what's new with this new Capella release that will be making life much easier for fast-moving application developers. And we're joined today by Jeff Morris, VP of Product and Solutions Marketing, as well as Matthew Groves, DevRel Engineer. So today, remember to use the chat function to chat with your fellow attendees or to ask questions. And please remember to check out our docs section. We will have a link to today's deck that will have some valuable information for you. And there's also a link to our next webinar that is coming up in July, which will feature Matthew Groves. It's called Putting SQL Back into NoSQL. So we hope that you will join us for that. And now I kick it over to Jeff Morris and Matthew Groves.
Awesome. Thanks so much, Suzanne. Hi, Matt. Great to see you. Let's talk today about the Couchbase Capella's spring release and its pending inclusion of Couchbase Enterprise Server 7.2. So as we go through our discussion, we'll first start out with what's in Server 7.2 in Capella. We'll touch on some new capabilities of Capella itself, extending enterprise deployability, addressing and enhancing the developer experience, and then highlighting some of the work that you've done on the continuing incredible price performance that we're seeing out of Capella when we look at it versus its competitors. So let's jump in. What I want to first remind everybody is just the basic core concepts of Capella and what makes it a compelling database as a service in the market is, number one, it's fast, as Couchbase traditionally has always been. That's due, of course, to our in-memory design and our built-in caching capability, where all activity that's happening within the database, within a database cluster, happens at memory speeds. This is actually what drives our affordability. The incredible price performance of Couchbase, where we are doing more work with less resources and therefore costing our customers a lot less money, is really what makes us that affordable. And in this day and age, that's becoming a bigger and bigger issue. But it also includes things like elastic scaling up and down, the introduction of Magma, our high data density storage engine, as well as supporting traditional capabilities of enterprise level databases like high availability, replication, disaster recovery, backups, etc. Matthew was giving me a little bit of a hard time a minute ago because he said our slide's getting a little long here in terms of the versatility of Couchbase. So I mentioned the cache, I mentioned the key value capabilities, the origin story of Couchbase, of course, being the combination of Memcached and CouchDB at the same time, two open source projects combining together, and the company sponsors that sponsored those projects combining their resources to build Couchbase, right? A JSON document database that's run at in-memory speeds. But then we started adding all of these other relational capabilities that everybody's familiar with, right? The not only the transactionality, but things like SQL query as our declarative query language, or full text search and the ability to look through an entirety of a document for particular keywords or perhaps geolocations. The ability to support operational analytics and do large-scale aggregations on active application data. One of our new capabilities we'll talk about in a second is support for time series data. But there's also the eventing and capabilities inside of Couchbase. Our active clustering capability, we're still pretty unique in that regard. Of every cluster node in Couchbase can accept a write or give a read, and that really clever thing of supporting workload tuning, our multidimensional scaling feature of being able to take any one of these particular resources that I've just described and apply, or these services, and allocate as much infrastructure resource as your application needs for it to be performing at its optimal capacity. Geosync and mobility is another rarity that you won't find in every other NoSQL system. And ultimately, so that's sort of the versatility of the platform. And finally, like I just mentioned, it's really as easy as SQL. If you know SQL, then you know SQL++. SQL++ is simply SQL for JSON. And then all of those core capabilities you expect out of what you're used to from a relational system like Postgres or Oracle, multi-document ACID transactions, or the ability to use your favorite software development kit for development, or the ability to have schema on demand and do things like joins amongst collections and amongst documents, but inside the database. So those core capabilities are all built into Couchbase, and that's what really, it's the holistic assemblage of all of these capabilities that really makes Couchbase special here. Both the dependability of relational systems combined with the performance and scale of NoSQL systems. I think that all of those are great drivers for us here. Now, what we've seen most recently, and we continue to talk to customers and prospects about what's bugging them in the market, and what is driving them to look at new data platforms or new database systems. And so here, performance continues to be the number one reason that they're looking for help. Right? They're seeing that existing databases are failing in their demands for millisecond response. And that happens for a number of reasons, but very likely a dramatic increase in the number of users or the number of hits that are happening to your database, because everybody's gone online and everybody's using their mobile devices to access your business critical applications. So that need for performance. I read a well-written email from a competitor of ours, and they said, latency is the new outage. And I thought that was kind of clever in terms of characterizing performance issues as being a big driver for why someone would look at something new. But that flexibility and that versatility is another reason, right? Is you don't want to be bound by having to roll out an entire schema schema change just because you wanted to add one column to one table, right? Huge hassle, still unresolved in the relational space, and that's really the impetus for using something like JSON. So your development teams lack that agility and face, if it's not agile enough for them, or if it's not feature rich for them, then you end up creating a lot more complexity in your architecture and in your application design. And and complexity is what creates bugs and performance issues and maintainability issues. So that downstream ripple effect of overbuilding your system, right, is a big driver. Third, as I mentioned, mobility, right? Everybody's online right now. There's more devices online than you can imagine. So supporting application functionality at the device level or at the IoT level, I think are increasingly becoming more and more necessary. And then finally, roll it all up, and generation 1 and 2 of let's move everything out of our data center and into the cloud. And now let's start building cloud things the same way we built our data center. Maybe use brand new NoSQL systems from the early 2000s and start building assemblages of capabilities. And guess what? Your cloud costs as much as your data center ever did. So that shocking cloud cost kind of sticker shock that our customers are experiencing, they really want to figure out how to reduce resource consumption. So those are really the things that we're seeing as drivers for why customers are looking at Capella, and why customers are looking for kind of the new capabilities that we're going to talk about now that are found in Couchbase Enterprise 7.2, and that Capella inherits by virtue of the fact that it's in the core database. So let's talk, Matt, a little bit about time series data and some of the clever things that we've done here. So Couchbase has extended our support in JSON for adding in time series data like change event logs and like statistics that are coming from system monitors, or things that like financial stock price data, right? When what did the stock open at? What did it close at during that time interval? All of those things are time series data. And some of the biggest things that I think I've ever seen in my life is, time series data gets really, really big and really, really difficult to manage very quickly, right? And even when you're getting status updates that are just saying, okay, 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 but those, that data still has to come across the wire. That data still has to get, acknowledged as being read. So coming up with ways to efficiently handle that, like eliminate the duplications when you need, or like, come up with efficient ways to gather the data and make it quick to access, like having an efficient index capability built into it. Um, Matt, can you think of other, particular issues that are driving kind of the desires for time series support in something like Couchbase?
I mean, you mentioned already, but definitely IoT devices and lots of data being generated by those devices on a constant basis. They never stop generating data, right? As opposed to a person who is active a certain time during the day, IoT devices are always going, always measuring, always logging something. So it's a very strong offering for IoT use cases.
Yeah, and I think even the rarity is, I don't feel like even in my house I'm a tremendous IoT device user, but when you really how many devices in your house have you got that are online right now? I think I got 25 or something like that. It's ridiculous.
Yeah, I mean, home automation stuff for sure, but even if you're at a retail location, there's sensors and devices everywhere that are doing all sorts of things. So
Yeah,
those really start to stack up.
big time. And the data that they're and then there's almost like overkill in the amount of data or the intervals that everyone wants to sample, right? Is to take in terms of, how quickly do I need to know if a change happened, and then what do I do with it if I didn't need that update, right? I think that just managing that volume, I think, is a big issue with, one of the drivers why time series became a thing. So let's look at that a little bit, and let's talk, Matt, about what we've done here in Couchbase is we've basically extended or taken advantage of the fact that a JSON document can have a substructure as an array or a subdocument inside of it. So you want to talk a little bit about what did we do in harnessing JSON to support time series data?
Yeah, I really like this approach because it doesn't involve like a whole new storage engine or a whole separate piece of querying or storage. It's all taking place in JSON that Couchbase is already very good at storing and handling and querying. So what you see on the screen here is just an example of how we're using some TS underscore attributes there to represent time series data. So you can have a start and an end and then individual data points. And you can see this is a very slimmed down version of time series data to remove all the duplication that would just end up taking up more disk space. So this is going to help time series be queried more efficiently. And I really like about taking this approach is that it is still JSON data. It's still the same pool of data. So if you have other information in this besides time series data, you can still query it with SQL. You can still look it up with key value. You can still search for it with full text search and so on. So it's all the same data, same pool of data, all these different multi-model approaches. I really think that's a great strategy.
Yeah, no, I completely agree with you. And the fact that it does take advantage of all of that core capabilities of the Couchbase architecture, the caching capability and the memory first design, as you just said, the direct key value access. If you know exactly what attribute you want to get in this document, go for it. But if you don't, use the search functionality to go find that odd change value that that you might be looking for, or that error message you might be looking for if it's a weblog. That sort of flexibility and just being able to add that type of data into the environment rather than creating a whole nother engine, which is what arguably Couchbase's core design was originated from. But the fact that we don't have to do that for this, I think, is a big deal. And can you think of other, how might we extend this particular model as we look ahead, right? Can you think of other capabilities that we might be able to support in the future? The one that comes to my head is graph, right? We could do almost the exact same thing of list out the adjacencies of a particular node and their relationships as a new JSON array and have the same kind of effect.
Yeah, and again, the great thing about that approach is you can use it's all JSON data behind the scenes, so you can use the graph functions, the graph API when it makes sense to, when it's more efficient to, and fall back to the other methods when they're more efficient or they're easier to write or faster.
Mhm. Okay, so let's look a little bit at, so what's the trick that we've got to do in terms of getting preparing the data that you might be receiving from your IoT systems? What do we got to do to it to get it into this array?
Right. So this is a few examples. This is one example of a SQL++ statement you can use to create a series of time series data endpoints. The only thing you have to really do different is you have to have a TS start, TSN, and TS data. As long as those are there, this can be treated as time series data. There's nothing on this slide here that's really new to Couchbase. This is, you could have created this yesterday with that same structure. We're going to see some more specific time series things as we go through the presentation. But as long as it's in this format, you can treat it as time series data. So you can use a SQL++ query as shown on the screen here. You can use an SDK, operations to insert and update that data. As long as it has that structure, it can be treated as time series data.
I love the phrasing, to pack multiple data points into your arrays, right? That's that's the real trick there, right?
Yeah, absolutely. So as we saw on the last slide, the data really is packed quite efficiently into that array because time series data can be very long and large. And so you want to pack as much in as you can.
Mm-hmm. Okay, so let's look at this time series function and how you might run queries with these time series extensions for for accessing and unwinding that data.
Right. So this is the new addition to SQL++ to handle time series data. As long as it's in that format, you can then use this underscore time series function to unpack, as you mentioned, the packing of data into an array that can then be used for whatever analysis you would normally want to perform. So it could be visualization or some trend analysis or forecasting. But the first step here is to unpack it with the underscore time series. And at that point, you can treat it as if it's just, regular JSON or even relational style data and perform joins and where clauses, whatever else you need to do to analyze and transform that query.
Cool. And then, this one amused me too, is clearly there was things that we needed to do to make time series support work even more efficiently underneath Couchbase. So improving our disk compression, our compaction of the data by creating some new Magma settings. Magma, of course, being the high density storage engine that we introduced a couple of releases ago. But make it so that this data is indeed stored as efficiently as possible.
Yeah, and Magma is a great fit for large amounts of time series data because you don't necessarily need it in memory all the time. But when you do need it, you want to query it as quickly as possible. So Magma is ideal for that. And then this just allows you to tweak that depending on your use case, the average size of your time series and so on. So this is just some more settings in the background to support time series.
So summarizing this whole thing, I think what we've just covered is really the cleverness of using JSON as this vehicle, right, to store these structures and continue to take advantage of those core capabilities like SQL++ in Couchbase itself to do your operations on it. So ingestion is pretty easy. It's really efficient and flexible in terms of how how you might use it and when you might use it. But then we start to take even more advantage of optimizing the storage underneath so it doesn't overgrow itself, or taking advantage of the fact that all you really need is the document index for everything that's in that array in the document, right? That's a pretty clever optimization. But I love the fact that you had described earlier as well. You can use things like search against all of this data as well. Any other thoughts on key takeaways here?
No, I think you've hit the nail on the head there, is that, Couchbase is not a dedicated time series database, but it does give you a multi-model approach so that you can use the right tool for the job within the same pool of data, whether that's time series or SQL or lookup or text search.
Mm-hmm. Okay, so now let's talk about a new feature. We kind of call this change data capture and streaming using Kafka to identify and capture all document changes. So this too is another one of those kind of capabilities that could get really unwieldy very, very quickly. Do you want to talk a little bit about this?
Yeah, so this is really the beginning of a larger change data capture features that are to come. But in this case, what this allows you to do is get a more detailed list of every single change in the server. So previously, those have been grouped up for efficiency reasons, but in special cases, you want to be able to get every single one of those changes and have those all come across in the stream. And so it's a specialized use case, but when you need it, you need it. So this is something that hopefully we'll see some more along the lines here in the venting world. But this is a step in that direction of getting a detailed change stream of data. Whenever something changes in the database, you can subscribe to that and get every single step of the way.
Yeah, and so this new this introductory kind of capability is we're using Kafka as the vehicle to be like, all right, here's all the subscribers that are looking for these kind of change events. Now go ahead and do something with it. Like, as a first start, I think that's super appropriate because of Kafka's popularity. But then I think you just alluded to that, you can foreshadow that the eventing service would love to have a similar kind of capability so that we could do that directly from within the database, as well, right?
Yeah, absolutely. Or even from an SDK or wherever you need it to get updated changes.
Mhm. Okay, so that's streaming with Kafka. Now let's talk a little bit about analytics. And what I like about this particular capability is where last year we were introducing the cost-based optimizer for SQL++ queries for the query engine, the main query engine. But now we've done the same thing, implemented the same functionality for cost-based optimization for the analytics service. So now your large-scale analytic queries are basically optimized automatically based on what our projections of the activity are going to be. So have you got any commentary on CBO for analytics?
Yeah, the CBO stuff, it's been in the relational world for a while, but doing that on JSON data has some unique challenges because, JSON data can be semi-structured and can have fields that are there or not there. And so creating an optimizer to deal with that is quite a engineering feat. And so now this is in the analytics engine as well, which just goes back to your original pain point of, hey, things aren't fast enough. This is going to help you get those dashboards, those BI reports, all that kind of analytics that feeds into your marketing data, as we've seen with our customer Domino's. It's going to get that stuff faster.
Mm-hmm. And then another change in addition for analytics is extending the remote links functionality. So talk about this for a little bit.
Yeah, so it's one thing to be running analytics queries on the data that's in Couchbase, and it's something even more valuable if you can correlate that and join that with other data sources you have in your enterprise. So, of course, we have those top 3 that are available and now supported. S3 is a big one, Azure Blob Storage. These are places where a lot of data can be stored in your enterprise. And we've got some developer preview support for Parquet and the Gen 2 of Azure Data Lake. So all these different places you can bring together data with your data in Couchbase and run SQL++ queries on them so you can get insights from across your enterprise.
The other capability that when we did the customer advisory board this a couple of weeks ago was one of the customers was describing how they're using the analytics service and this data linking service or this remote linking capability to link different Couchbase clusters together so that they can have aggregate analyses from going on among Couchbase clusters and amongst that other external data that's in the cloud. So I think we need to keep reminding people that analytics service in its own right is pretty robust and has some really clever capabilities to do, cross-cluster kinds of data gathering that you might not necessarily remember or think of. So let's talk a little bit about some of the new things that we're introducing in Capella itself, right? So these are kind of the capabilities that you might find in the in the in the overall environment you might see in the control plane in Couchbase Capella if you're getting started. So Matt, if I'm getting started and I run across this memory only bucket feature, what does that do for me?
Well, it just what it says in the tin. Your data is stored only in memory. There's no disk involved, so memory does not get saved to disk. Now, why would I want to do that? Right? Because the memory is somewhat volatile. Well, the reason you want to do that is, again, it comes back to performance. If you don't have to worry about the overhead of reading and writing to disk, then you're going to get much faster speeds. Now, of course, it has to be for certain use cases. You can't just always put everything in memory. So something where it's a transient data where you're just processing it, or if it's temporary data like a cache or user profile or security tokens that expired, JWT tokens perhaps you could store in there. This is a great feature for supporting those use cases.
Yeah. So the traditional customers would recognize this as ephemeral buckets in Couchbase Server, but we're manifesting that as memory only buckets in Capella, just to be a little bit more just to explain it directly, kind of what it's doing. So now when you go into that interface, you get your choice of 3 different bucket options, right? You get memory only, you get Couch Store is the original storage engine, and then Magma as well as the newer storage engine that's available to you in within Capella. Okay, so the second one is some automation and manageability introductions. The one that I like a lot is the hibernating the databases or hibernating a cluster. But let's talk about the other 2 here.
Sure. So these are also just kind of what they sound like. Dynamic disk expansion means that, as you need more disk space, we can just kind of automatically give you more disk space. You don't have to go and re-provision anything. It will just expand as you need it to. And then downloadable buckets is just kind of a feature where you can download your data directly. Then the reason you want to do this is if you had some sort of compliance or security issue and you want to get that data, or maybe you have some backup requirements that you need to store it somewhere other than an S3 bucket or something, you can download it and put it wherever you want to.
Yeah, I think so in some cases super obvious, but also super useful. And hibernating clusters, right, is not only I recognize that as being good for us when we're managing trials and things like that, where we give you 30 days to the product, but maybe you've only taken 22, and then rather than keeping the those environments up and running and basically just burning electricity in a in your cloud provider, we can end up hibernating them, shutting them down until you want to access them again.
Yeah, developers, we've all done this. We've all left something on overnight or over the weekend. We shouldn't have. So this allows you to, again, just kind of go back to those 4 pain points. Reduce those cloud costs by hibernating when you don't need to use the databases.
The developer sticker shock on that has got to be pretty bad, right?
Yeah, it can be a little mortifying.
Yeah. Okay, so and I think making things more both accessible and going where the customers are. We've added 10 new regions across the 3 cloud providers. We're adding larger instance sizes for within each cloud provider, so that you can get a bigger a cluster instance instead of scaling horizontally. I think that's a pretty cool benefit. And then now we're available on all 3 cloud marketplaces. So you can execute private orders through that, take advantage of your own cloud discounting that you might have negotiated with your cloud provider. Those are usually things that are available through marketplace-oriented purchases, and Couchbase supports that as well now on, like I said, all 3 clouds here. And then finally, Matt, let's talk a little. Or we've got HIPAA compliance on Google Cloud. I'll hit these ones. You hit the next ones. And then private endpoints in Azure. So we're continuing to evolve all of these at a pretty rapid pace, right? The HIPAA compliance for Google Cloud, I think, came along very, very quickly, and private endpoint support to make sure that all communication that's going on between your applications and Couchbase itself is nice and secure. Both capabilities here. And then let's talk about enhancing the developer experience. What do you want? I think you're familiar with both of these new integrations, but tell me about them for me.
Yeah, sure. So Netlify is a very popular uh, cloud deployment environment for Node, JavaScript developers, TypeScript developers. And so what Netlify and Couchbase have partnered up to add is a Couchbase Capella integration for Netlify functions. So what this does is it just reduces the amount of friction that you need to manage your connections to Couchbase from Netlify, and so you can spend less time worrying about that and more time, writing code, which is what developers want to do. And speaking of writing code, Visual Studio Code, we've got a great new extension, Couchbase extension for Visual Studio Code that includes a Couchbase Explorer, so you can check out all the scopes and collections and browse your Couchbase data right from Visual Studio Code. Don't have to leave the IDE. And it also comes with some snippets built in. So some quick little samples of code that can help you connect to Couchbase, execute a SQL++ query, run a text search index. All those things are available as snippets now if you install that Visual Studio Code extension. Now in the marketplace.
Cool. Yeah. That's both of which are pretty awesome. You've recently, or I guess very very recently, just started your code streaming activities again. You want to tell me about that for a second?
Yeah, that's true. So I am now streaming on Twitch. If you want to check it out, twitch.tv/Matthew D. Groves. I'm going through the process of building a open source implementation of a sample architecture called Conduit. And I'm doing so with a little bit of help from our friends ChatGPT and Google Bard and GitHub Copilot. So we're doing some AI integration there as well.
Very very cool. And give the URL for that again.
Yeah, twitch.tv/Matthew D. Groves. That's 2 T's in Matthew.
Great. Okay, let's give you a little bit about the developer experience that we've been working on in here. I'll start with the right-hand side, as we did redesign the developer portal, what we were calling it before, to really become its own part of our website, the developer experience part of our website that highlights things like the playground and the development resources, the developer resources that we have. It takes an approach by adopting the style of, we're presenting the problems that we anticipate developers experiencing, and then what Couchbase kinds of capabilities you might need to help you resolve those particular problems. But in terms of other things here in the Capella UI, any narrative around those, Matt?
Yeah, so one of the benefits of a database as a service or any software as a service is the ability to iterate very quickly on those and make changes for the better. And so we continue to improve the UI just to make it a smoother experience for developers. The primary thing when we're getting started is, well, how do I connect? So you can see on the screen here, it's now just quick 5 steps, and along the way everything's explained. So the idea is to just make it a smoother experience, and you're going to see more and more improvements as we go along in Capella.
Very good. And now let's talk about some of the other activities that have been going on for Capella, including some of those core capabilities like performance testing. We like to sponsor performance tests. We work with an organization called Altoros to do that. I'll talk about that in a second. But remember, right, the beauty of Couchbase is that it offers you all of these core capabilities, in a singular database, and allows you to operate upon a single pool of data, right? Your single environment of storage, where perhaps you have redundant copies of the data, replicas for availability's sake or for recovery's sake, but you can still access all of those using all of these different data access methods. And now, of course, I need to update my slide here to include time series access as well. But supporting all these different types of workloads, you get all of this versatility of Couchbase as this singular system. And then when we look at that, right, we take all of those things, and now we continue to, like I said, sponsor Altoros to go and run benchmarks on our behalf. So let's talk a little bit, Matt, about the Yahoo cloud serving benchmarks that we're sponsoring with Altoros. What's tell me about workload A and kind of our results here.
Workload A is 50% read, 50% update. So it's a very update heavy workload. And it's something that Couchbase is really, really good at. It's right in our wheelhouse, as you can see from the charts here. The chart on the left is total throughput. So the higher, the better. This is the more operations that it can handle in a period of time. And so you can see Couchbase there is the best throughput at workload A. It's doing quite well there at all different levels of scale, from anywhere from a 3-node smaller cluster up to a bigger 18-node cluster.
And so I think some of the interesting things to note on these tests right now is, one, we went small in addition to large in this particular activity, where we've added 3-node tests for all of these activities, as well as we added in another vendor to look at, which is Redis Enterprise Cloud. Any comments on either of those? Like, what can we expect to see as we continue to look at these?
Yeah, so we're going to look at some other workloads that are different approaches in a 50-50. So you can see the full details of the report and how those workloads, what they're for, what the use cases might be. So this is sorry, you just went to workload C right here.
I think what the setup I think I was going for there was, I think what you're going to find is that these tests are highlighting the strengths and weaknesses of every vendor. Right. And in many cases, right, like this one highlights one of the strengths of Redis Enterprise Cloud, and as well as the continuing competitiveness of Couchbase Capella itself. But the other thing that I like about this is it also illustrates why someone would go and combine things like, let's use Redis as a cache in front of MongoDB as my JSON store. And you can kind of see why people would do that now.
Absolutely. And this is back to that slide from a couple slides ago where you showed all the logos up there. Sometimes, an architecture is just a bunch of point solutions, right? So I bring in a Redis for cache, I bring in Oracle for relational, I bring in Elastic for search. But the long-term costs of that are pretty tremendous, right? So not just in the licenses, but in the work I have to do. So I have to learn 3 different SDKs. I have to patch and upgrade 3 different systems, and possibly pipelines between them, as you mentioned, duplicating data. Those have to be upgraded, built, and patched and maintained as well. So you're really getting kind of a explosion of costs there as you keep adding more systems into your enterprise. And so certainly Redis has performed very well here because, like Couchbase, they have a memory first architecture. But this is maybe perhaps an additional cost on top of other databases for Redis, whereas Couchbase can do all those different models, different ways to access data without needing another cache on top of it, because it has a cache already built in.
Yeah, at the same time, and even so, you're right. Look at the price points on how much it takes to run a billion operations, and Couchbase is incredible. Is very, very competitive across the board here, right? Even when the Couchbase's throughput number might be running a snitch behind, still on the your price performance is outstanding. Tell me about the pagination workload. I always consider this one to be sort of like building a scorecard for a video game, or like, who's the top 10 now?
Yeah, that's the kind of use case where you might have a lot of data in a collection, let's say, but you don't want to show all million rows on a web page at once. You want to get a page at a time, maybe 50 or 100 at a time. And so a pagination workload is exactly what you need for that. A very common use case on the web. And you can see here that we've actually omitted, so who do we omit? We omitted DynamoDB because it just wasn't something that Altoros could pull off. They just weren't able to do it. So it's just Mongo, Capella, and Redis on here. And again, Redis is really great at workload C. Pagination, not so much. It was very poor performance there for Redis. It was almost unfair to include them, really. But there they are, and Couchbase obviously doing great on pagination. Not only the raw cost, but if you look at the actual code to write a pagination query with Couchbase, it's really basic, straightforward, easy to read SQL that's familiar to developers and easy to write.
Awesome. Okay, so so Capella continues to maintain its price performance advantages here, and one of the things that we found is that when you look at all of the capability I have in the upper left hand corner, right, you can end up doing the majority of that capability with Couchbase on fewer resources. So in many cases, if you have one of these polyglot persistence kind of designs, right, you can replace multiple databases at once and eliminate, in many cases, our customers tell us more than half of their infrastructure in order to enjoy better performance from a less complex design using this all-in-one kind of architecture of Couchbases. The net effect of that is people like you, Matt, right? You can develop code faster, write less complex applications, but still get the robustness of functionality that you're seeking. In that whole goal. Polyglot persistence was a design idea that really encouraged developers to take on the complexity in order to deliver the features, right? But now, I think you can get save time, improve the quality of your output, and save money on infrastructure and development costs all at the same time, without sacrificing the feature functionality of your application. Any additional thoughts on kind of that assertion?
No, I agree with that. And, it's just all those hidden costs that you don't think about when you're spinning up a point solution here and there. At development time, it may seem okay. I just have to learn one more SDK, but in the long run, those costs start to stack up. And especially when you get to production, and you deal with all the problems of patching and upgrading and data pipelines, it can really, really stack up.
Okay, so summarizing, like we'll kind of bring this this event home. If you've got questions, please and feel free to chat with your colleagues in this in our chat window. We will respond to you and get information back to you if there's a question that goes unanswered here. But Couchbase Server 7.2 is available for download. It supports new time series capabilities in JSON. We support that change streaming of document changes to Kafka now as change data capture. And the cost-based optimization for analytics is now available. And you can link to Parquet and Avro files directly in S3. For Capella, that memory-only bucket feature is the big deal, as well as the development environment integrations that Matt just walked through, and the fact that he's using these right now, right? I think that's a really clever and important capability. But dynamic disk expansion, hibernation, downloadable buckets are all now coming to Capella, and those environmental enhancements, right? We're expanding our cloud footprint, our cloud support, making bigger instances available, et cetera. All of which make the spring release something we're really excited to be talking about. So as I wind down, and Matt, feel free to throw in, but the things that I continue to notice, this was reinforced with our customer advisory board meetings that we've just held, is why does anyone pick Capella? It's just fundamentally we're right now we're a better value. It's that performance, scale, the tunable architecture of Couchbase to make sure that even as your application evolves, that tunability with multidimensional scaling, the flexibility of doing all this work in JSON makes it much easier for teams to maintain a high performance application. That access to JSON and our ability to shrink your footprint by reducing the number of databases that you might require for your application is a big deal. And then mobility, right? We're seeing a big uptick in mobile delivery. Gaming is, we added a number of new gaming customers again very recently. It's as easy as SQL, right? The robustness of our software development kits are still a great advantage of ours, but that's making sure that it's easy for developers to be productive. And then, like I said, our Tech Validate has continued to inform us that 55%, so more than half of the customers we survey, right, say that they've cut their infrastructure costs by half. All of these are pretty big values, I think, for the modern development team who's trying to build something clever for their customers. Any thoughts here, Matt?
I mean, easy as SQL is a great point. It's one of my favorite things about Couchbase is being able to write SQL and be able to read SQL as well.
Mm-hmm. Okay, so if you want to find out more information, certainly jump in. You can look at how to modernize your application. Our sort of instruction kit of looking at why you would pick something like Couchbase. We've got a growing library of videos, and that latest Alturas benchmark report is available, and Matt's blogged about it in terms of what the results that we're finding from that. But if you want to try us, right, prove it yourself. Try the playground, excuse me, or try Capella itself. And even if you want us to help you construct your own TCO model to actually help justify why moving to Capella is a good idea, we'll help you do that as well. So, Mr. Groves, thank you once again for your participation and help here. Spring release is a pretty good one.
It's good stuff. I can't wait to see what's coming up next.
Me too. All right, so thanks everybody, and look for us again. Matt's on Twitch now, and you're doing another event, the SQL to NoSQL data modeling course, kind of coming up soon too.
That's right. Putting the SQL back in NoSQL. That's the next webcast coming up.
Excellent. All right, thanks everybody.